Everyone, in this video I'm going to talk about pointer arithmetic as well as a few things that I have missed in the previous video. So let's get started. So what I will do first is I will just uh, write a basic int main structure for the C++. Okay. Okay, so now what we can do is let's make a pointer. So how do we make a pointer is by writing int star and p. Now this is my pointer, but let's say we want to make 2 pointers or 3 pointers or declare 2 pointers or 3 pointers. So how can we do that? So the genuine thing would be to write it like this, p1 and p2. But let's say we have defined the pointers in this way, so we should expect that both of these should be pointers. So let's check type info and then let's do std colon. Now if you are thinking why I write this std all the time in front of this cout rather than using namespace std is because that sometimes if I make a function or a program in which I do not include this, or if I give it to somebody else who has not included using namespace std, so it would give some errors. So it's generally a better way of writing it out. Okay, so let's find the type of this type of the pointers. Okay, so what I should expect is pointer to int. As you can see in this is pointer to int. Let's try to find what is the type of p2. So if you are expecting this to be a pointer as well, so bad luck, the p2 here is not a pointer, it is a int type. So in order to make this also a pointer, you need to specify it like this, in which at every declaration you have to add a star in front of the pointer to declare that this is a pointer. Okay, so also there are different types of pointers, like pointers to int, pointers to different type of data types. Also there are pointers to pointers as well. How do you define a pointer to a pointer? So a pointer to pointer would be defined by double star, and double star, let's call it p3 for the time being. Let's also define some variable. So how can we define a variable? Let's say a is my variable, and let's say its value is let's say 10. Okay, now what we can do is we can assign the address of a to the pointer p1 with the help of AND operator. This just means AND is address of a, and it is given to p1. And now let's try to print this p1. Okay, so what we should expect is it gives us some address, as you can see in the terminal window. Let's dereference it. So if we put a star over here, this means that it is dereferencing. So we should get the value 10, as you can see in the screen in the terminal window. Okay, now what we can do is rather than doing it in this way, we can also define a pointer to this pointer p1. And what we can do is since we have defined p3 to be a pointer to a pointer, what we can do is we can do AND p1. Now what this means is this means address of this pointer p1. So this means address of pointer p1 is given to p3. Now if we want to print this out, what we need to do is, let me just copy this, be a little lazy, and let me just clear this part. And what we can print is let's print p3, and let's print p1 as well. So when we run this, as you can see, the two addresses are different, but what we can do is we can do a trick. We can dereference this pointer, and what we should expect is the address of this p1 as well as the dereferenced value of this. Okay, so what I mean is this p1 has a value stored in it. Okay, so if we write star p3, we should get the value same as what we are getting with p1. Okay, so let's check that out. As you can see in the terminal screen, it is the same value that we are printing. Now what we can do is, okay, now what we can do is we can do not fine, I can do this, and let's okay, so let's get rid of this thing. I'm not deleting this for now. What we can do is let's do dereferencing twice. Let's see what we can get. So if you think how we should do this, so what it means is, so this C++ will interpret it in this way. So we have a pointer which points to a pointer that points to an integer. Okay, so this essentially, as you can see in the pop-up above as well, it just means that it is dereferenced twice. So it will give us the value of a. As you can see, if we run this, we get the value 10. So this just means that this and also if we try to print the type of this pointer to pointer, you will see that this is a pointer to pointer which points to an int. Okay, as you can see, p means pointer which points to a pointer which points to an int. Okay, so I think this part of video is really clear. Now what we will do is we will try to do some pointer arithmetic. Okay, so let me get rid of all of this and let's start fresh. Okay, now what pointer arithmetic means is, see, if we define int star p, now this is a pointer, it points to a integer. So an integer in memory is given something like this. It has 4 memory blocks. So one memory block is equivalent to 1 byte. So it has let's say I am writing these memory blocks as this. Okay, so I have written the indices of these memory blocks. So what a pointer will do is, pointer will point to these pointer will point to the first value of the integer. Let's say my integer is stored in these 4 memory blocks. Okay, so the pointer will point to the first value. Now if I do p plus 1, so what it will do is it will shift to the next integer that is stored in this. So what it will do is it will point to this value. Okay, and we can check this out with the help of our pointer arithmetic, but note that only 2 operations, which is addition and subtraction, are possible in pointer arithmetic. No multiplication or division is available, and also those don't really make sense. We just add and subtract in pointers. So let's check. Let's initialize it and point it to some variable. How we can do that is we define a variable. Let's define it again a. Let it have a value of 1, and then we have a pointer, and let's do std colon cout. Okay, so we have some address. What we can do is we can add p plus 1, p minus let's take p plus 2, and then let's do p plus 3. Okay, so let's see what this thing gets us. So as we run this code, we should get some addresses. As you can see, we have some addresses, but we cannot really interpret them unless we know how to interpret these hexadecimal numbers. So what we will do is we will now define a function which gives us decimal numbers. So we will do a typecasting. If you don't know what typecasting means, is it just essentially means that you are converting the type of a variable to a different type. So this is my hexadecimal number, and I will do okay. So now we will use these numbers instead of these. So what we can do is we can do hexadecimal to this, and we can do this, and let's do this. Okay, plus 1, plus 2, and plus 3. Okay, I'm getting some error, and that is okay. So another thing that I need to do is I need to typecast this one as well. Before I have not done typecasting, that was the issue. So now we are getting some values. Let me do a blank line to differentiate between the numbers. This would suffice. And let's run this. So as you can see, this is my address of P, and this is what I get when I have P plus 1, which you can see is exactly this value plus 4. So this essentially means that, as I have told you in the theory, that the pointer moves to the next int, so next block of 4, and that's where the type of this pointer is very essential. Since int is of size 4, as you know, the size of int is equal to 4, and what I have defined is if I take a long, or not even long, if I take a double, so a double has a size of 8. So if I make a double pointer, a pointer to a double, so what it will do is it will move to 8, it will move to the next 8 memory cells. So that is why we need the type of pointers as well. Okay, that's it for this in this video. We will talk okay, so that's it for pointer arithmetic, and some things that I have left in the previous video. I concluded them in this video as well, and I'll see you guys in the next one.